Hi everybody, welcome to another episode of the Future Tech Podcast. It's me, Charlie Sell, Board Director of the Major Group, where I get a chance to speak to thought leaders, people passionate about STEM in the many forms, science, technology, engineering and maths, to find out a bit about their story, to discuss a topic they're super passionate about, and of course finish on that all-important career advice. So I'm really pleased to have Dimitris Vlitas with me today. Dimitris is an associate director at Accenture, specialising in AI, and my gosh, is he passionate about it. We've just been having a great discussion about how that can be used, and I think a lot of the topics we'll discuss today will really resonate with many of our listeners. As I think we all agree, AI is one of the most futuristic and is here to stay, and we really need to learn how to properly use it. So, without further ado, Dimitris, welcome to the podcast.
Thank you, Charlie. Very happy to be here.
Let's jump straight in and tell us about your story. Tell us a bit about your career.
Yes, okay, excellent. So, as you all know, AI, the way that we're experiencing today, it's a relatively new technology. Yeah, it existed in the era of Turing and so on and so forth, but the way that we're experiencing today and all the conversation, it's relatively, I would say, 12 years old since 2012 that we had back in University of Toronto, Jeffrey Hinton and the team, they make the big breakthrough on imaging. So essentially for me, obviously, my story, my trajectory that led me to AI and where I am today started way earlier. When I was living in Greece, I'm born and grew up in Greece, to go to North America to study without having at that point I didn't even, we're talking about 2001, and at that point AI didn't exist. It was an obscure thing in the department that was called computer science, obscure in the sense after, since the era of Turing and so on and so forth, which essentially these guys, they just scratched the surface of automation. That's what they were doing at the time, really. Today we call it automation. And we didn't succeed in surpassing that, and then the AI fall in just a tiny part in a computer science department that back in the day in the university they were telling you, actually don't even go and do that because you're never going to get a job. Yeah, it's so obscure, and so think, okay, out of completeness we have that thing, but neural nets, they don't work in the way that we expect them to do, and so on and so forth. So for me, in theory, I became a professor of mathematics. Yeah, and I get my appointment. By the way, I got fostered immediately, and I'm extremely lucky about that, by the community at the University of Toronto, which is a simple Google search. You will see this is the place that brought AI in life in 2012 in the way that we're experiencing today. So for me, I was innocently I'm a professor of mathematics there, doing my PhDs, doing my things. But then I was lucky enough when in 2012, the Jeffrey Hinton, and which actually is a British guy, born and grew up here in England, which in a certain point moved to Canada, and you guys, you should be extremely proud of this guy, yeah, and did a breakthrough, show that certain architectures of neural nets that perform image recognition better than everyone else, yeah, and overnight, actually, it seems that overnight, after since the 50s, it took us like 62 years later to have an actual artificial intelligence performing a task that already surpassing human level performance. And then these guys, they ping me over because my research in mathematics essentially was doing combinatorics, that for those who know, it's a very major part of AI. So overnight, I left my mathematics background and I jumped into AI, which means in the university, just changing a floor on the same building. I moved my office from the fifth floor to the fourth floor. So, and overnight, I became, again, way far from industry, an academic that was doing research on AI. And at the time, I did 10 years ago, didn't even think that I would be in industry. Yeah. at all. It wasn't on my aspiration. It was nowhere close. It was just a very interesting new subject that I felt intuitively that I can contribute greatly on the research. Yeah, but then the thing that is good, and I think it may resonate with a lot of people here, is very quickly, 2012, what happened? Google were very keen and they came to the University of Toronto and they immediately bought the copyrights of that ImageNet, the AlexNet, as we call it, and for those who are technical, we still call it AlexNet today, that particular architecture. And Google immediately created the terms of law and all the tooling in order to help you do your coding on AI, your coding life easier, which is the things that we still use up to today. So very quickly, I realized that, okay, research on AI, and this is what I have been doing in my life for 15 years up to that point, it's great, but then we're talking now about a new form of intelligence that provide you so many capabilities, which is they're going to affect their everyday lives. So very quickly I realized that industry, it may provide you a more exciting place to be because you are going to take this technology, you are going to take the research that you're doing, and you're going to have the exciting task bringing it to life in everyday manner. Yeah, which is so far in my academic years, your research was accepted by the scientific community and stayed there, and very rarely you would have impact in everyday life. So for the very first time, we're in this unprecedented position that I was receiving emails from IBM. I was receiving emails from Xerox, this big printing company in America. I was receiving emails from all these players asking me, okay, we'll give you a bunch of people to do a project which essentially at that time, the project was AI to perform a single task, to tell you if a printing machine is going to collapse or not, predictive maintenance, or IBM, they going to cluster a demographic, or whatever was happening. So very quickly, I realized that the industry and the everyday life can provide you with very challenging and nice projects to do, and very important both in terms of the society, very important both of the of the evolvement of AI. Because remember, in academia, your everyday task, your research, is to invent new algorithms, and new algorithms, which means that they perform a task. Industry, though, has industry cares about optimizing end-to-end processes, which means orchestrating many tasks together, which is that is not the job of academia, really. I mean, different KPIs, yeah, which is another way, another very challenging thing to do. So very quickly, I realized that ahead of us lies a greenfield opportunity, and of bringing science is not happening in every day. As a scientist, very few times through the human history, a scientist is given the opportunity to bring the everyday research at scale at industry. This is not happening once every 50 or 60 years or so. Yeah, at least in the science. Maybe if you do biology, it's a different thing. In the science of mathematics and computer science, I'm talking about. Yeah, or in medicine, they made are different KPIs which I'm not aware of. So I was flirting there, therefore in the beginning I was thinking industry wasn't for me, but then going through that trajectory, and then in a certain point I get acquainted with various people meaning companies, and Accenture came along the way while I was in North America. I'm European, I wanted to come back to Europe, and they offered me the position to lead AI here in UK, and I took it, and this is how I jump here. So out of that trajectory, what I want you to think, you youngsters, it's essentially to be open to the new things, to be willing to take a little bit of risk, to leave your comfort zone, because now in 5 minutes I try to describe you what happened the last 15 years, and it sounds like a nice story, but when what is happening, I have to tell you, I have a lot of people telling me you are crazy, in the sense Even if you move from university from one department to another, the computer science, they think you're mathematicians and you're not going to belong there. So you're leaving your comfort zone to jump in unknown territory. Then from academia, I was jumping to industry. And then people that were telling you, the industry people, they think quite different. You're not going to be successful there. It's going to be hard. Ignore them. You go there and so essentially follow your instincts, follow your things that they make you happy, they make you passionate about, and you make things. And this is, for me, if you like, the recipe of success. Don't necessarily go by the book, because you see, I did all these jumps that by definition they weren't very promising. People that were telling you or leaving very established things from academia, being at Cornell University in the States, in University of Toronto, or in Canada, which is a simple Google search, you will see they are the top 10 universities of the globe. They belong, but very willing to leave those positions to jump into unknown, and to new things. And this is what I think, and in particular, technology is going to ask you if you want to, is going to ask you to do constantly if you want to remain relevant. Yeah. So, okay, this is, I hope I communicated my career trajectory.
Yeah, well, and I was saying to you earlier, just it's so refreshing to see the passion of people, and as you said, that moving from academia into industry and those, people's reservations or telling you it can't be done. What's lovely is you've shown that you can move from one to the other, and you're obviously driven about adding value and wanting to see practical implementations of a topic you're so passionate about. So it's fantastic.
Exactly.
So tell me a bit more, Dimitris, about the world of AI. To many of our listeners, and we were talking about it earlier. Just talk to me more about the world of AI and what you see.
Okay. Yes. AI, what is it? Yeah. I mean, it boils down to a very simple thing. Yes, it's a very complicated technology to bring it to life, because for instance, you hear that my friends actually and collaborators, the OpenAI people, they say they train these multi-billion parameter models, and people, they see all these numbers and they're very scary things. So you have science, yeah, combined with very good engineering, what is actually means practically to be able to have the platform and the technology to be able to train those models, and then you have to bring up to life such a highly and great performance tool. Yeah, but let's break it a little bit into components. It's way less simple that you think about. So essentially, we start with data, and on those data, I mean, either it's text, whatever it is. Yeah, AI does a very simple task. Yeah, AI essentially is a probabilistic model. Tells you with what probability, high or low or whatever, certain data occurs. That's all it is. Yeah. So the scientific part of AI is to be able to model the data, to model the probability distribution of the data source, even if this data is text or it's images or it's data about people or what have you. Any sort of data that AI consumes, the science is to be able to 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 come up with a probabilistic model that correctly or as good as possible predicts the occurrences of certain sentences or certain correlations of words if you are talking about text, or of pattern recognition if we are talking about us humans or what have you. And then having been successful on this part, that you have a certain algorithm that does that, yes, then you need a very good engineering, because AI, in order to learn, it has to do many iterations through the data, as humans. How we learn bicycle, it's always we go, we fail, and eventually after repetition, we learn how to bike. That's all it is. We're never going to go to a school for bike. So repetition is a major component of the human learning, which is actually what AI does. AI has to go through many times through the data in order to learn the pattern. And in order to go many times through the data in a reasonable amount of time, we need very good engineering. We need big compute power. And the billion parameter models that you may hear and they sound very scary, essentially is allow an expressive power to the probability distribution, because the more parameters that you have, the more you're going to be able to probabilistically model correctly the data sources. So essentially, you need a very big compute power and engineering to be able to go through vast amounts of data quickly, and then you need your algorithms to have a lot of neurons and a lot of which is going to allow to the science and to probability estimators a lot of expressive power in order to do your probabilistic modeling correctly. And that's it. That's what AI is, essentially. Which, of course, yes, it's a very scientific thing because you have to understand how to model things, because there are many ways to do that, and you have to try and you have to understand each probabilistic model, what it does, and so on and so forth. And then you have the engineering, and then having done the training successful, then you have an end product that performs a task as we all are aware of. Yeah. So essentially, this is how AI is experiencing today.
Yeah, wow.
Yeah.
And thank you for breaking it down into, such understandable chunks. Because obviously, as you said, it's an incredibly complex world. But to understand the overview of it can be quite simple when you think about it from being able to create the algorithms of data, and from that, what you can do then with the actual practical use. So, for many of our listeners who are thinking about wanting to get a career into AI and explore that further, what one or two bits of career advice would you give to our listeners to be able to get
Okay.
a foot in the
Okay.
door?
You told me just before we met, Charlie, that usually your audience is quite of young people. I mean, yeah, which is great, because young people, youth is always, we're still more elastic, more agile when you're, and then age comes in, and usually, typically, people we get so the fact that you are young, which means you're still in school, or you are going through your studies, or you recently finished your studies, or you are in that thing, it's an amazing thing. Why? Because, as I mentioned previously, AI essentially is a science above all, or a science or engineering, however you're gonna call it. Yeah. Or I put all these things under the same umbrella. Even if you go and create chips that they're going to allow you and give you the computational power to do all these iterations that we're talking about, or you're going to be a computer science, meaning creating those algorithms that their job is to get the probability distribution out of the data, or you're going to create an amazing UI user interface that at the back there is an AI system that does many things. Okay, no matter how you're going to do any of those things, yeah, you have to have it's a technology, it's a science, which means you have to get yourself acquainted with that in various levels or in various degrees and various levels according to what you want to do. Yeah. So which means uh, you have to get yourself to get a little bit your hands dirty with science, technology, engineering. Again, being able to have something intelligent to say and to be able to. It's like if you're a cook, you have to know your ingredients and you have to know your things. Otherwise, you're never going to be able to have a good soup. Yes. So essentially, any sort of acquainted and the good news is today as we speak there are many platforms out there. There is Coursera, that Stanford is a great learning platform that Stanford has done it almost for free. There are many educators that they do spectacular job and they give you different sorts of education from academic point of view, education from industry point of view, education from practitioner point of view. There are trainings, there are certificates that people they start actually recognize and so on and so forth. And if you and another thing, if you decide to go through that path, because as you know, AI is the innovations they come to AI space by the month, not by the year, which means you have to constantly upgrade yourself. Yeah, it doesn't mean that fast AI, yeah, which I love. and it's completely free, and you can go there, you can take those courses, and if you take those courses, they're great because very quickly they bring you in the front line of AI. But you see, every month or every 6 months, are completely new things that they come into the thing. And for you, or for someone that wants to go down that path, has to make sure that himself or herself, or they are willing to be up to speed constantly. But this is the exciting thing, because the new things they come by the month, it gives you an enormous opportunity to innovate. It gives you an enormous opportunity to do things. Yeah, it's a very alive thing, which is in the one hand demands you, but in the other hand, it gives you an enormous opportunity. And those things, they go hand by hand together. Yeah.
Yeah, fantastic, Dimitris. What great advice! And what I loved about that was, as you say, you've just got to be so inquisitive, don't you? And you've got to make that step, and you've got to be passionate about the ingredients of the soup, not just wanting the soup. So what really makes the fundamentals of AI, and as you say, with the amount of training out there now, the platforms, the opportunity, I think people have got to follow their passion, don't they? And if you're passionate about it, you're going to be successful in it.
Exactly. Don't go there. Okay, I know the market is very hot, and it's one of the highly demanding and highly paid jobs, which is good because all of us will have to have a nice job. But don't go for the money. Go there, find a way. I mean, that what you love, and see yourself, what you're going to bring to the table, what your contribution is going to be, what excites you, what attracts you there, and go for that. Yeah. And go for the thing. Yes, okay, it's good that all of us will want to have jobs, and all of us will want to feel desirable. Yeah. And to have people and asking us, and it's a very good thing. But you are gonna mark your territory, you're gonna make a contribution in any scale, and doesn't matter the impact of the contribution, smaller. To do that, you have to bring your own DNA, to find your signature, if you like. And that, in order to do that, you have to know how the thing it works, and you have to make it yours, and then eventually you're going to be able to come up with to have your original point of view, and regardless what the impact can be. Yeah, from a very small platform up to very big players, and so on and so forth. But you have to love it, and you have to invest yourself on that, and this is the thing, really.
Yeah. Well, thank you. So, Dimitris, time has flown by, like in every great
Excellent,
podcast
yes.
that we do. So, it's for me to say a massive thank you to you for being a
Very
guest.
welcome. Very happy to be here.
Amazing. And to our listeners, that is another episode of our Future Tech podcast. As many of you know, it's shared with the STEM Ambassador Association, as well as on our website, themajorgroup.com/podcast, and on Spotify. So one more time, a massive thank you for Dimitris. And to our listeners, that is another episode of Future Tech. Thank you.